Hello everyone, welcome back. This is the second in my series of GeoGebra tutorials. This is where we left off last time. I'm just going to change this horizontal scale here on the x-axis back to normal. So submenu for graphics, settings, then x-axis, and I just untick the distance factor there and we're back to normal. So that's just a little bit nicer. Now I want to add in another function. The nice thing about GeoGebra is that I can see that one's there and I can keep on entering more. But this time I want to be a little bit clever. I want to have the ability to change the period. That number 5 there represents the period of the function. So one complete cycle here happens in 5 horizontal steps along the x-axis. I want to use a parameter in my new function and I'll call the parameter t. So I click in the input box and I give this thing a name. Now notice that it gives me the choice to create slider. I'll accept that choice and it defaults to being t ranging from -5 to +5 in steps of 0.1. As you can see, I can change the value of t with this control. It doesn't make a lot of sense to have negative values for, beg pardon, I just need to left click there. It doesn't make a lot of sense to have negative values. So it doesn't even make sense to have 0 value. So I'll go 0.1 as the smallest time period, up to, let's go 10, and we'll have steps of 0.1. So now we can control that just the way we want. And I've got a parameter here, t, ready. It doesn't seem to do anything on the graph because it's really just a variable sitting in the memory of the computer. The display button just puts the slider here on the graphics view, exactly just a mirror of what we've got there. Now here comes my new periodic function. I'll call this one g of x. I only want to have an amplitude of 1 this time. It'll still be a sine function, 2 pi over, this time I'll refer to t as the variable that I just set up, multiplied by x. And I'll also have a phase shift on this one of pi over 2. I don't want to worry about a vertical shift this time. And there's my new function, g of x, sitting down here. If I go back to that slider control, I can see the effect of changing the value of t. T of 0.1, a very short period or a high frequency, so lots and lots of little waves there, and all the way out to t equals 10, a very long period or a low frequency wave, all the way out there, one cycle in 10 horizontal steps. Whether those steps are time or distance or whatever depends on the physical thing that you're trying to model with these functions. Now, interesting things happen when waves overlap, when two waves get into the same place at the same time. And we can model that mathematically by literally adding the two functions here, f of x and g of x. So I've clicked here to give a new input, and I'll go a new function h of x equals f of x plus g of x. And I literally just have to type this bit here. The computer knows, it remembers what the definitions of these functions are, and it displays them correctly. I'm happy with the way that's going. I'll hit enter. And as you can see here, the purple line, that's the purple dot, purple line. Purple line is the sum of these two waves. So for instance, at the moment, when at the 0 point here, my little red g of x, it had a value 1. The green one had a value 5. 1 plus 5 gives 6. So we end up with a combined crest which is higher because the two crests are in the same place at the same time. They add together. Over at this point, the green function has value 5. The red one now has a value -1. So 5 minus 1 gives a height of 4 for the combined function. This is a point where the two waves are working against each other. And so we get a slightly reduced size of this crest. Of course, that's just if we had a really long wave. If I change the value of t for the small wave, we get some very strange things going on, very strange combinations. And that's something that a physicist or some other scientist. These waves could be a biologist looking at changes in population density of different species in an environment and how they interact with one another. So wave functions, these types of periodic functions, are used by all sorts of different scientists to model different physical or biological systems, and this is really just about the maths of how that one and that one interact to produce this complex wave. If the diagram looks a bit messy at the moment, remember we can use these controls here to turn off the functions from the display and just see the one that we're interested in. That's enough for now. I'd encourage you to have a try with some of your own functions, and this idea of using a parameter is not limited to just one. I could have put a parameter A for amplitude, and I could have put a parameter phi for phase shift, and I could have, and I just wanted to keep it simple and have one parameter to play with. Usually it's a good idea to change one thing at a time and see the effect that's going on. That's enough for now. See you next time.